start. We will have to review some matrices. Did you learn matrices before? Don't worry if you didn't. I will review everything, it's fine. It's always like that. American schools are not very synchronized. Some of them covered something, some of them didn't. I got used to it already. So it's okay. We're gonna first review determinants. Determinants have different notations. Either DET and then bars, A, B, C, D, E, F, G, H, I. Or just double line. Actually, just one line, that's what I like to do. One line, that's already a good notation. But some people like DET and brackets. Now, by the definition, let me explain you how to do it. Don't just copy. So copy the first part, this one. How to find DET of the matrix. The matrix, for you to know, let me show you that. We're not going to work with matrices in this class. Matrix, only with determinant. Matrix is the collection of the data, right? A, B, C, D, E, F, G, H, I. Matrix is a collection of the data. Data can't be numbers. 0, 1, 0, 1, 0, 1. That's how computers communicate with each other. Can be data of the patients in the hospitals. Also matrix. Columns and rows. Excel file, basically, it's a matrix. And then determinants, they have lots of information in it. So in this case, we're working with inputs of the vectors. Of course, there are also matrices with vectors in it, which is pretty cool. Okay, so how to write down the definition of determinant of 3 by 3 matrix. We'll be doing 3 by 3, mostly. You take the first, we're going to do only the first row. You can do many different ways. In this class, we're only going to do first row. You multiply the first row, first input by the determinant of the leftover. So there's an old computer game, which was like in the 90s, I think. You draw a bomb over here, and the bomb blows up everything vertically and horizontally. That's exactly how determinants work. Very nice visualization. A bomb destroys the whole vertical and horizontal lines. So you multiply by the determinant of whatever is left, which is this piece, E, F, H, I. Then you repeat for B and C. For B, it will be negative. I will explain in a second why. B is negative, minus B. So put a note here, minus B. And then you draw a bomb. It destroys like so. And you multiply by the determinant of the leftover, D, F, G, I. I'm reading rows. D, F, G, I. Show with my nails. D, F, G, I. That's the one that's hard to visualize because it's kind of broken into pieces. Finally, the last one, plus C. So usually people do plus, minus, plus. A, B, C. Plus C, again, the bomb destroys everything in a row, in a column, and you have D, E, H, D, H, D, E, G, H. D, E, G, H. That's a definition. To be honest, most of us don't remember the definition, we just do it. It's more practical tool than actually a theorem in this case. We just know how to do it. The same rule applies to matrices 4 by 4 by 4, 5 by 5, 11 by 11, and so on. So this is what I found, and that's like, wow, this is super confusing, so I kind of don't like it. But yeah, I found it in the book. They show plus minus things, but this is one of the ways some of you learned it. That's why I copy paste it here. You don't have to copy this. Some American schools teaching it this way, so students told me if it's correct. I'm like, well, yeah, I can see it's correct, but it's very confusing to me, so I did not dig into it. Bless you. Now, why it's plus minus plus? In general, make a note at the very beginning. The determinant of the matrix. So this is the brace. The parentheses are a matrix. The brackets are determinant. Determinant. That's the international notation. Americans like to write down DET, but actually just 2 bars are good enough. And then the signs are just changing all the time. Put in different color. Plus, minus, plus. And now you keep changing. So if the previous was plus, the next one will be minus, plus, minus, plus, minus, plus. And for 5 by 5, it's the same thing. You just keep changing the sign all the time. But since we're only working with the first row, you don't need to remember all others. Determinant can be found in different ways using any row. So in this class, we only use the first one. So I don't need to explain you others. Determinant. Good? Yes?
Sorry, but if it's more convenient to use the method that is on the right.
Yeah, you can do it, for sure. Yeah, thank you for asking. That's why I put it here. So it's in your notes in the PDF file. If you like this method, feel free to use it. I don't mind. Yeah. Some people, that's exactly why it's there, because people asked me about this last time. I just use whatever I like, but doesn't matter. Just use whatever you know you're not going to mess up. Simple as that. Yeah, good job for asking. So, example 1. Let's write down what they're saying. Example 1. For the given matrix A, 2, 0, 3, 1, 2, 1, 4, 1, 2, find, this is the correct notation. So matrix has parentheses, while the determinant has bars. Sometimes they write DET of A. Both are correct notations. So you will see both notations. Bars. Let me show you this. You'll be doing this even on the final exam. So this topic is so important. What I was learning today is so important. Some people who got jobs in architecture and mechanical engineering and others, they just do this all day long, basically. I asked many. So that will be pretty important. Cross product is important. For now, we're just learning how to work with matrices. Idea is, I will take 2, multiply by the determinant of 2, 1, 1, 2. Minus, so remember, minus, right? Plus, minus, plus. I will take 0, multiply by the determinant, doesn't matter, because it's 0, so I just skip it. Make sense? But actually multiplying by the determinant, 1, 1, 4, 2. Finally, plus, I will take 3, multiply by the determinant of 1, 2, 4, 1. This is how fast you do it, and you will learn how to do it this fast. I promise you, literally after this homework, you'll be doing it fast. So, no, seriously, don't be afraid. In general, students like matrices to work with them. We even teach matrices to business students, and I think this is like the best topic they like the most until we get to double integrals, they don't like it. Actually interesting that the students, business students do learn some vector calculus a little bit because it's there in business. So plus 2 multiplying by through or drop the bomb, and then whatever is left will be new determinant, so bars, and I will have 2, 1, 1, 2. Ask me, does it make sense? Yeah.
So can you multiply that entire new determinant by 2?
Yeah, exactly. So this, I don't like this notation because it's a cross, but basically it's just a product. It's not cross product, but a product. Yeah, exactly. And then I have to teach you now how to find that determinant, but that's actually simple, so it's fine. Now, minus, remember that the second one is minus, so I'm erasing everything. That's why it's nice to use a pencil or just don't do anything. I have to visualize it because here I can erase quickly, but in your pencil notes on paper you cannot. So I'm using 0, so minus 0 multiplied by a new determinant. What kind of? Drop the bomb, whatever is left. 1, 1, 4, 2. 1, 1, 4, 2. And the last one is plus. Here it is, drop the bomb. 3 is multiplied by 1, 2, 4, 1. 1, 2, 4, 1. How about that? Yeah, exactly. I keep switching to the next one. So now I have that. Just to show you, this is the game I was talking about. This is one of the first games in the 90s. This is the amazing graphics of the time, when 8 megabytes was lots of space and everything. So you drop the bomb, and the whole point was if you have enemies, it would destroy everything on the column and everything at the row. So you want those enemies to collect somewhere on here, and then you drop the bomb. Very cool idea. And then you have to hide also, because that will destroy you too. So it's exactly what we're doing here. If I'm dropping the bomb here, it will destroy everything like so. So that's exactly how you calculate determinants. A very smart way to visualize it. And that's why my friend, he put bombs here. It's like literally a bomb. I don't know. It reminds me of something different, and I don't feel like that is good. But okay. Now, so you have those tiny determinants, how to calculate them. 2 by 2 is calculated using this formula. Super quick. Check it out. If you want to find determinant of A, B, C, D, that's a 2 by 2 matrix, so we want to find determinant of a 2 by 2 matrix. It goes like this. Cross product A times D minus cross product C times B. That is a formula, you have to memorize it. But luckily it's pretty visual. Cross minus cross. Like so. So now we're going to do that for each tiny determinant we left to calculate. Cross minus, does it make sense? Cross minus, and again, it's actually minus for a reason. Plus minus. Remember, we always keep switching the sign. So, but usually people remember cross minus cross. So let's calculate it. Now I will show you how quickly you will be able to calculate it after this homework. So I'm calculating the determinant of the matrix is 2, 0, 3, 1, 2, 1, 4, 1, 2 equals from the very beginning without writing down all those long notes. Usually people don't do it. That's too long to write. Lots of things to write. So people do it this way. So let me do it from scratch the way I would do it. And then you will see, and then you will, I promise you'll be doing it that fast. So I'm taking the first, so I'm putting plus minus plus, not to forget. 2 is multiplied by, I'm visualizing with my hands. Usually people use a finger. They close the column, and then they close the row, and they see, oh, 2, 1, 1, 2. And instead of writing it down, they actually do the cross product now. 2 times 2 minus 1 times 1. 2 times 2 minus 1 times 1. Does it make sense? Bless you. That is using this formula I just did. Carefully erasing. 2, 0. So that's the determinant of the 2 by 2 matrix. Minus 0, and I would skip that because 0 times stuff is 0. But in the sake of the formula, I guess I should show you what it will be. So let's put it in green. Okay, so 0 is minus. I remember that. Good job. Minus in the middle. I'm dropping the bomb, and I know it's going to be determinant of the 1, 1, 4, 2 cross product. 1 times 2, 1 times 2 minus 4 times 1. That's how people remember it. It's mostly visual than actual formula. 1 times 2 minus 4 times 1. Like so. Erasing, writing it down. 1 times 2 minus 4 times 1. And the last one is plus. Let's put it in a different color. Plus 3. This is the matrix 1, 2, 4, 1. The determinant will be 1 times 1 minus 4 times 2. 1 times 1 minus 4 times 2. And then you calculate the answer. And you calculate carefully. The answer is minus 15. This minus 15 tells you so much information. You're going to learn it in linear algebra and differential equation classes. How this information of determinant shows you lots of stuff. In this class, we just cover one of the application, cross product. So, again, the formula is the same. A, B, C, D, AD minus BC. Visually, people just remember it like so. Cross minus cross. So this is the practice how to find determinants. And now we're actually going to be using that. Questions before I move on to cross product? What do you think about that? Application. Don't have to write this down. Just like 2 by 2 determinants I used to calculate areas of the parallelogram, 3 by 3 I used to calculate volumes of the parallelepiped. Do you know how to say parallelepiped in Russian? Parallelepiped. So let me show you this. Before we go, there will be a cross product. It's a vector. I think cross product. Okay, good. This is the important part. So let's write down cross product. Cross product and dot product are going to the final exam. It will be exam 1, 2, 3, and final. It's extremely important. Basically, like your substitution was everywhere. Cross product will be everywhere. Cross product has a notation. It has a cross. Cross product is one more product. Let's do vector A cross vector B. So now you cannot just put cross because you like it. Now there's two different products, the dot product and the cross product. So cross product is an English name. And I told you I never heard it before. And then I realized because we call it a vector product. Because the answer is a vector. It's called a vector product. And that is a nice name because it hints the answer of the exam question. Is the result of the product as a vector or a constant? If it's a dot product, we call it a scalar product. So the answer is a number. Scalar is a number. If it's a cross product, it's a vector product. So the answer is a vector. So product of two things can give you different results. Okay, so the formula, we're going to have several formulas. Let's not write down this. This will show up later. Here it is. Cross product between A and B, both are vectors, is the size of A, the size of B, magnitude, times sine of the angle between them. And don't have to write down this. This comes from the determinant, so it's actually just easier to show as a determinant. That thing has lots of applications, and that's just one of them. You can find angle between vectors for using sine. But last time we learned how to find angles between vectors using cosine. The answer will be the same. So you obviously don't use this one. It's too hard. Usually we use the other one that we learned from the previous chapter. But the answer will be the same. There are lots of applications. Check it out. So draw this. Very interesting. If you have a vector A on the floor, and vector B also on the floor, so that's XY plane. Then, if you do, so let me show you this. The determinant of those, from those two vectors, that will give you the area of the green part, so the area of the parallelogram, which is in Russian parallelogram. And then, the moment you add the cross product, here it is. So all of those are vectors. The cross product, those three vectors will create parallelepiped. Do you know how to draw a parallelepiped? So this is perpendicular. A times B is perpendicular, sticking up. Then you make those parallel, go up. So this actually is not good enough. You copy the box and then you connect. That becomes the volume of the parallelepiped. Cross product gives you the volume of the parallelepiped. And it's just one of the applications. Other applications are actually more important. The cross product is in blue. That's the vector sticking out. It's perpendicular to the plane. That's a pretty cool idea. So now we will have a cool perpendicular vector. Not only perpendicular to A, not only perpendicular to B, it's perpendicular to the whole plane. So the cross product is 0 in length when A and B point in the same or opposite direction. We're going to learn about this. And reaches its maximum length when vectors are at right angles. So it is growing up and down. And that's a pretty cool tool to find out how the vectors are looking. So this is too complicated to show you without the animation. That's why I have animation here. Check this out. How cool is that? Cross product. So this is what I just showed you. Cross product is sticking out perpendicularly, but it will change the size. Cross product, so the dot product shows us how parallel vectors are. If vectors are very parallel, dot product was large. So the dot product would answer the one we had in the previous class. The dot product answered the question how look-alike the vectors are. If the number, it was a number, the dot product gives you a scalar, was big, then vectors were close to each other or even parallel or close to be parallel. Perpendicular, it would give you 0, so they're very not the same. This one is the other way around. Cross product gives you the understanding of how perpendicular vectors are. If they are perpendicular, cross product will be very long vector. The answer is a vector. The pointing direction matters. It will show you how vectors are collaborating with each other. So it points down when A and B are in different order, which one goes first clockwise and counterclockwise. And it's small when vectors are close to be parallel. You see, when they become parallel, it's 0, but when it's close to be parallel, it's also small in size. But when they become perpendicular, the cross product is huge. So basically, the question which I like so much, how perpendicular the vectors are. Very perpendicular, very not perpendicular, a little bit perpendicular. That's a cross product. It answers that kind of question. And this is the formulas, and we're going to learn right now how to calculate all of this. So, there's one more. This is the parallelepiped I just showed you. Parallelepiped created from the volume of the parallelepiped, created from the cross product swinging in the 3D space. The bigger the cross product, the bigger the volume, because then if it shrinks, the volume shrinks. And all of this comes from the matrix. So let's do that. Let's calculate. Write down. This is the most important example. After this, they're more or less the same. If you can do one, you can do all others. Calculate cross product. You see, this notation is so important now. This is not just x, not just 5 times 7. It's a cross product versus dot product. So it's very important to see the difference. I have a whole video in my YouTube channel describing the difference for your homework. A is 1, 2, 3, B is 4, 5, 6. Don't have to write down all of those writings. I will just tell you that it's a vector, not a number. It is a vector that is perpendicular to both A and B. In fact, you can check that both are perpendicular. I will show you later how to do it, but the dot product is 0. That's how we check. Solution, and that's your homework. And quiz 2 next week, basically. A cross B. Do you want bars or arrows? Which one do you like more? Yeah, I like them too. I put bars if I'm too lazy, actually. I actually do notice that. Equals. Create a determinant. There are only 2 vectors, so it will be 2 rows. What is the third vector then? The third vector is, the first one is I, J, K. I, J, K. This is well-known unit vectors, I, J, K. Basis unit vectors. And then you put your vector A. It's over here. 1, 2, 3. Then vector B, 4, 5, 6. 4, 5, 6. In order, like so. That's the beginning. You created the determinant of the matrix that has 3 rows. The first row is IJK, and then your other 2 vectors. So we're finding cross product between those 2 vectors. And now we're going to perform what I just did with previous example. I goes first. Here it is. And it's a vector. Put it there. I is a vector. I is 1, 0, 0 if you don't remember. Times. The first determinant will be, who wants to tell me? 2, 3, 5, 6. I'm dropping the bomb and I see the leftover. 2, 3, 5, 6. Amazing. Good job. 2, 3, 5, 6. Now, plus J. I'll make a couple mistakes on purpose to see that you're paying attention. Minus, exactly. Be very careful with this. That's like a very upsetting mistake people make. Because then everything is wrong. So minus. People put plus, minus, plus. Or just remember the second one is minus. Now, I'm dropping the bomb. What is the determinant? 1, 3. Let me put it in purple. 1, 3, 4, 6. Yeah, so you have to, you can put a pencil or your hand. Some people put pencil and they cover it visually on your paper. And then they see 1. I already forgot. 1, 3, 4, 6. And the last one is plus K. What is the determinant? 1, 2, 4, 5. Again, whatever is left is 1, 2, 4, 5. Usually people don't write this down. They actually calculate the determinants right away. So it's the first time I will do it. The last probably time. The first and the last. I, J, K are vectors. So I is a vector multiplied by a number. The number is 2 times 6 minus 5 times 3. Also probably the last time I will actually write it down carefully. 2 times 6 minus 5 times 3. cross product with negative in the middle. Does it make sense? What do you think about that? People at the back? Good job. Thank you for sum up. I asked people last time during office hours how soon you zone out in this class, because it's 1 hour 15 minutes, so it's hard to pay attention. And people were very awkward to tell the truth that they do zone out fast. The statistic says, or the study says, it's in 30 minutes usually we all zone out. So it's kind of like important to make some kind of screaming voice in half an hour to wake everyone up, or some activity, or sing a song, or I don't know. But even grown-up people cannot stay for 1 hour, 15 minutes. And then ask kids in middle school, they will not even stay for like 15 minutes, paying attention. So try your best. Minus j, who wants to tell me 1, 3, 4, 6, it gives you what? 1 times 6 minus 4 times 3. Agree, disagree? People? Yeah, good job. Cross product with minus plus k times 1 times 5 minus 4 times 2. Calculate that and you have the answer. The answer should not be a number. That's very important. The answer should be a vector. The vector is minus 3i plus 6j minus 3k. Let's just algebra quickly calculate. And the same way to write it down is minus 3, 6 minus 3. That is the same notation. I know you're getting used to this, so that might be a little bit weird, but soon you will see it's the same thing. You're either writing it down as a vector notation we started with, or using unit basis vectors, I, j, k. Both extremely popular. So you have to get used to both. That is the answer. That's what we call cross product or a vector product. Vector product, which should give you a vector. So if you got a number, that's wrong. Not too bad? Yes?
How did you know to like start off with IJK in the first step?
That's from the theorem. Very good question. How do we know to put IJK? That's a theorem. It kind of explains how to do the whole cross product. You can check it in the book. You see, I'm trying to skip too much explanation because I think it's too much already. But IJK is kind of this basis where you start with, and all those numbers get attached to the corresponding ij and k, and the answer is a vector because of that. If you put all the numbers in, it will be a number, blah, blah, blah. But yeah, basically IJK is unit vectors. They point in the same directions as whatever we need. And then those numbers are calculating the cross product. No, good question. The easy answer is it comes from the theory, basically. Why do we do IJK? One thing to mention is the property. You don't have to draw this picture. Just write down a note. Note. You can write down right after this example. Note. The cross product can be switched with the order, but you have to switch the sign. B times A now is multiplied by a negative. Then the cross product will look down. It will look down instead of up. But then what is down and up in 3D if everything is just keeps spinning? Right hand side rule helps to figure that out. Unfortunately, everything is in terms of right hand all the time. Called, well, it's the same as we did before, but basically this is the idea. If you take your right hand, not left one, right hand, and then A and B can be in different order, right? This can be B and this can be A, so the order will change the direction. Whatever you multiply first is A, whatever second is B, even if it's called C and D, whatever, the order matters. If A goes first, then A times B is perpendicular pointing up. If you have to flip your finger to get A first, then it's pointing down. It's easier to explain with 3D animation than with words. So I have it here. So you see, what is up and down in 3D? It's flipping everywhere. So that's why it's important to know the order matters, clockwise versus counterclockwise, or the hand rule. Whatever goes first multiplies in the second one, they go together, points up. Or Whatever goes first folds together on top of the second one, goes down. That creates those perpendicular vectors. They describe lots of important things and behaviors. So we did this one, and I wanted to show you this. Oh, that's gonna go next. Check it out. So look at that. Look how pretty cool is that. So I'm moving it with my finger. See? So Z is not always up. Z can be whatever you want it to be. The red angle, the red vector, is cross product. It's very big because green and blue are far from each other. They're almost perpendicular. The more perpendicular they are, the longer the red vector cross product is. So that's how it's sticking out. How do you know which one goes where? Again, if I'm going blue goes first, and then blue goes first, and then the pink one, then it points down. But then if I go like this, let's see, Z, then blue goes first, but this way, and goes up. You will see it's actually better. Someone coded really good problems in your homework to visualize that. Okay, that's good. That's good too. Next. What else is very important is this. Single most important property. You don't have to write this down. Just put exclamation mark. I like exclamation marks. Here it is. A times B is a vector, and it's perpendicular to both A and B. So that is the idea here. If you draw, we already draw it, so you don't have to. A and B, cross product is a vector that's perpendicular to both. A times B, A and B. If they are shrinking towards each other, the cross product is small in size, but still perpendicular, just can be tiny. And 0 if they are parallel to each other. So perpendicularity is very important. Parallel. Okay, so let's write this down. Properties. Remember, let me review. Right on top of properties, write down that I, reviewing for you, 0, 1, 0, 0. J is 0, 1, 0. And K is 0, 0, 1, called unit basis vectors. We covered them pretty a long time ago. The first class, I think, or second class. So if you see that the cross product of two vectors is 0, that indicates that A and B are parallel. Vice versa. If A and B are parallel, the cross product will be 0 vector. So if they are parallel, like so, the cross product will be a vector, which is just a point. So it's a 0 vector, 0, 0, 0. 0 is a vector. Remember, it's not a number, because the answer should be a vector. So it's completely the opposite. So let's write down versus, or comparing. When A times B is 0, and now it's not a vector. A times B 0, it's a number. That's a dot product. Do you remember what that means? A is perpendicular to B. So in the previous class, we learned dot product. Dot product. Your homework will ask those questions, and your test will ask those questions. Dot product is 0. What does that mean? Cross product is 0. What does that mean? Remember, the dot product or scalar product tells you how parallel things are. So if it's 0, they are not parallel. What does it mean to be not parallel? Perpendicular. Cross product tells you how perpendicular things are. So if cross product is 0 and it's a 0 vector, then they are not perpendicular. Then that means they are parallel. Both are pretty useful. A times A itself is 0 because A is parallel to itself. That makes sense. And again, it's a 0 vector. B times A is minus A times B. We wrote this down. Any combination of I, J, K gives you the other vector when you do cross product. That is because I looks towards you, J looks away, and K looks up. So they're all perpendicular, I, J, K. That's why they are so awesome. They're actually part of the property. In the angle formula, we wrote it down. If you find the length of A cross B, magnitude, that gives you length times sine So this is one of the ways to find the angle between the vectors. You can find sine of the angle using cross product. What do you think about this? Finally, last thing to mention, scalar triple property is kind of But last thing to mention is whatever you see on the test. Usually we ask you to find. I solved some homework problems in my notes. I can show you here. Those are some homework problems. And I have YouTube videos on those homework problems. So definitely if you stuck too much, just check this out. But the last thing to point out is we will ask you in your homework and usually in the test to find the volume of the parallelepiped. So I showed you this. This is pretty cool. Area of parallelogram is the absolute value of A cross B. But then if you want to have, I guess let's write it down. Fact, area of the parallelogram is A cross B. That is this area. So again, if the vectors are parallel to each other, there is no parallelogram, then it makes sense, area will be 0. If vectors are perpendicular, that will be the biggest area can be. That's a rectangle. So the cross product is the biggest. But it cannot be negative. Area is a physical object, so we put absolute value. So area is base times height, right? Now, triangle. They will ask you to find triangle in your homework. Just take half of that. So write down. Area of triangle is half of the area of the parallelogram. Some geometry comes into the picture, basically. And the last thing we ask you to find is this example. Maybe it's actually written. Let's see. A times B, length times height, triple product. Find the volume. Oh yeah, this one. Too fast? Did you guys copy this? The area of the triangle is half of the area of the parallelogram. So half A times B. Finally, this one. The last thing to show before the quiz. Find the volume of the parallelepiped. Parallelepiped. Lots of L and lots of pi and lots of I's. And E and A. This is a very hard word. Parallelepiped because it's parallel. With sides, and each side is a vector. A, B, C. So very interesting, parallelepiped was created with vectors, not just segments or sides. A is a vector, B is a vector, and C is a vector. It makes sense. You have 3 fingers, it creates a parallelepiped. The 3 sides of this room, the 3 corners, this corner, that corner, and corner is up, creating the room, and the room is a parallelepiped. That's the idea. It's a box, basically. To find the volume, you basically find cross product of, you basically find this determinant. Maybe let me put it in red. It's a formula. And you now put them all just 1, 2, 3, 1 minus 1 minus 2, 2, 1, 4. So now it's not going to be a vector anymore. That's a number, which makes sense. It's a volume. So volume is a number after all. How did I know to put 1, 2, 3 and blah, blah, blah? The vector A. A is a vector, and it was given as 1, 2, 3. B is a vector, and it was given as 1 minus 1 and minus 2. Finally, C is a vector, and it is 2, 1, and 4. C is a vector. If you don't have vectors, you have points. Guess what you do? You create a vector. Next point minus previous point. That's what you did in your homework. And then you calculate exactly the same way. I'm not going to do it right now. This multiplied by determinant minus 2 multiplied by determinant, blah, blah, blah. And you get a number. And the number ends up to be minus 9. Okay, so the volume is minus 9. No, just don't forget to change the sign. Enter. Answer. Absolute value of minus 9 is 9 units what? It's a volume. Units? Cube. Thank you. What do you think about this? while you're finishing writing down, let me tell you that cross product in physics, if we lighten a bolt by applying a force to a wrench, we produce a turning effect. Apparently, that's called torque, right? Torque. That is a cross product. So let me show you that. So wrench, when it's spinning, when we try to push the wrench, so R is the length of the wrench, blah, blah, blah. So F, this is the force. We're putting it down. That creates a cross product. It's perpendicular. That is the idea. I have animation for that to show you. So people who like physics should be happy. See? Spinning effects, all of those are cross products. So if you're engineering, that must know for sure. Physics as well, must know for sure. Computer sciences, just enjoy the class. But again, it is useful in computer games, but somehow I see it mostly in physics, so I don't really know. According to the theorem, the magnitude of the torque, the size of the torque vector, where theta is the angle between the position and the force vectors, blah, blah, blah. So again, I was like, what is going on here? Look at this. It also has connection with, that's computer game, right? It has connection with the cross vector, a cross product of vectors, but like, what? I think they're trying to make like an object that is running, but that is not running. I totally agree with that. And finally, this one. So all those notes are given. You can check all those animations. So this is what they're explaining what they do here. They bullet solver feedback, local space torque. They're trying to code its lag, and the lag is lagging. And it's not working, so people helping here as always. In the forum, trying to help what to do with it. Why it's running away, nobody knows. Yeah, but all of this has cross products. Oh, maybe it's a puppy. No, but they're trying to like make a body for. Yeah, it is. You see? Look at this. It's wants some snacks. That is pretty cool. So that's how you create. Okay, now computer scientists have to also be curious about this. Apparently, it's very useful when you create computer games. Who knew? I did not know that. Very good. Questions about anything? Questions, comments, critics?